Hey there, and welcome to The Explainer. Today, we are exploring something absolutely crucial: precision and purpose. For the next few minutes, I want you to step into a totally new role. Imagine yourself as a scientific apprentice. You see, every great builder, artist, and scientist completely relies on their tools to turn brilliant ideas into reality. But having a cool toolkit just isn't enough, right? You have to know exactly how, when, and why to use them. So let's decode the secrets of using these tools with real precision and purpose. To set the stage for our entire investigation today, think about this ancient proverb for a second. Wise people store up knowledge. Now, this isn't just a nice, poetic saying. It is literally the absolute foundation of all good science. True wisdom and a true understanding of the universe around us, well, it starts with our ability to gather accurate, reliable information. If we want to store up knowledge that actually means something, we have to make sure the data we're collecting is the real deal. It's like we're building a house of knowledge. And precision? Precision is the concrete foundation.
Okay, let's dive into this. Have you ever ruined a perfectly good experiment with a tiny, totally unnoticeable mistake? Maybe you were baking, and you misread a teaspoon of salt for a tablespoon. Or maybe you were building a model and cut a piece of wood just a tiny fraction of an inch too short. It is incredibly frustrating. In science and engineering, a tiny measurement error right at the beginning can completely wreck your final conclusions by the end. You put in all that hard work, the whole shebang, but because of one tiny slip-up, the final result is basically meaningless.
Bad data is kind of like the ultimate villain of our scientific story. And the tricky part is, it loves to hide in plain sight. It sneaks in when you read a measurement from the wrong angle. Or maybe you accidentally use the wrong scale on a spring scale. These just seem like harmless little oops moments, right? But the problem is, these small errors compound. They snowball into completely wrong conclusions. If you want high-quality evidence, the exact kind of evidence that solves mysteries and builds bridges, you absolutely must have precision. Precision is your shield against the hidden dangers of bad data. So let's look at how we build our defense strategy.
Think of this as your master craftsman toolkit. To turn your raw observations into precise data, you have to match the exact right tool and the exact right unit to the specific task at hand. And you'll notice we use the International System of Units, or SI units, for pretty much everything. If you want to measure the length of a textbook, you'd grab a metric ruler and use centimeters. Need the mass of a rock? Grab a balance and measure in grams. Volume goes with the graduated cylinder in milliliters, temperature with a thermometer or probe in degrees Celsius, and time, of course, with a timer in seconds. These relationships are literally the vocabulary of science.
And this brilliantly illustrates our next major rule: choosing the right scale. Just imagine, for a second, trying to measure your entire classroom desk using tiny little millimeters. You'd be sliding the ruler 50 times, losing your place, and honestly, probably losing your mind. But measure that exact same desk in centimeters or meters, and you've found the sweet spot. It's the appropriate scale, it's efficient, and it's way more accurate. Matching the scale of your tool to the size of your object is a real game changer that prevents so many unnecessary headaches. Now, as a scientific apprentice, you're definitely going to encounter some jargon. So let's demystify one of my absolute favorite scientific words right now: the meniscus. Sounds complicated, but a meniscus is simply the curve seen at the surface of a liquid in a graduated cylinder. When water sits in a glass tube, it kind of clings and climbs up the sides just a little bit, creating this U shape. Mastering exactly how to read this curve is absolutely critical, because if you read it wrong, your volume data is going to be completely compromised. Let's actually treat this like a mini mission. Your goal: measure exactly 27 milliliters of water. Step 1, choose an appropriately sized tool. A 50 milliliter graduated cylinder is perfect for this. Step 2, and actually, scratch that, this is the most crucial step: you must get your eyes exactly level with the liquid. If you're looking down from above or up from below, you experience what scientists call a parallax error, which basically tricks your eyes and makes the liquid look higher or lower than it actually is. Finally, step 3, always read the measurement directly from the absolute bottom of that U-shaped meniscus curve. Do that, and you have conquered parallax error for good. Okay, here is another piece of pro-level vocabulary for your toolkit: tare. T-A-R-E. To tare a balance means to calibrate or zero it out, completely removing the mass of your weighing container. Think about it. You almost never put a messy chemical powder or a jagged, dirty rock directly onto a super delicate digital scale. You put it in a dish first. But obviously, you don't want the weight of the dish messing up your data. Taring is the ultimate pro move to ensure you are only measuring the exact thing you actually want to measure. Let's see this in action with another mini mission: finding the mass of a rock. Step 1, turn on and completely zero your balance. Step 2,
Place your empty weighing dish on the pan and hit that magical tare button. The scale will instantly drop back down to 0 grams, basically making the dish invisible to the machine. Then, step 3, add the rock to the dish and record the mass. Now, what's really interesting about this is what happens if you just forget step 2. If you forget to hit tare, your final recorded mass is going to include the rock and the dish, completely ruining your measurement and leading your whole experiment to a totally false conclusion. No way we want that.
We've talked a lot about traditional tools, but science is always evolving. Think about tracking a classroom's temperature over 10 minutes. If you use an old-school glass thermometer, you might check it manually once or twice. It's low resolution. It only gives you a tiny snapshot in time, making it incredibly easy to just miss subtle patterns. But switch over to a digital temperature probe, and it's logging data every 30 seconds automatically. It provides this high-resolution flow of data that instantly reveals hidden scientific patterns and rapid changes that you would literally never catch with the naked eye.
Upgrading with technology isn't just about making your life a little easier, though it definitely does that. It's actually about making your investigations significantly more powerful and reliable. Digital timers and data probes practically eliminate human reaction time error. Then, when you take all that data and plug it into spreadsheet software, it organizes thousands of data points instantly. Tables and graphs get generated in milliseconds. Suddenly, these complex mathematical patterns become incredibly easy to see, understand, and share with the entire world. Technology literally amplifies your ability to store up true knowledge.
But, having all the best tools, the most accurate data, and the absolute most advanced technology, it actually brings up a much deeper question. Consider this stark truth for a second. Education without morality will hurt. As we transition from talking about scientific accuracy to moral accuracy, we're really touching on the core philosophy of the HeroesmartAcademy Godly Learners series. You could be the most brilliant scientist in the world, perfectly capable of measuring the universe down to the millimeter. But if your heart and your moral compass are broken, well, that education can actually become a really dangerous weapon. So, the crucial point is this. What is the point of being incredibly smart and highly educated if you just continue to make bad choices that hurt yourself and the people around you? Think about it. We literally just spent all this time learning how to perfectly calibrate a scale and how to avoid tiny little parallax errors, all because we know that small mistakes ruin the final result. Well, in the exact same way, if we don't calibrate our moral choices, all of our scientific brilliance won't save us from a ruined, harmful life. A precise mind absolutely must be paired with a strong moral compass.
And that brings us to a really beautiful promise from Romans chapter 8. The mind governed by the Spirit is life and peace. Just as perfectly chosen tools bring absolute clarity and accuracy to a laboratory experiment, keeping your mind spiritually focused brings absolute peace and clarity to your everyday life. When you intertwine biblical morality with your education, you aren't just memorizing facts, you're learning how to actually wield those facts for good. You're removing the bad data of poor choices, and you're inviting true life and peace into your daily experience.
Which leaves us with one final, incredibly powerful question to ponder as we wrap up today's explainer. Will you use your perfectly trained, educated mind to simply gather data, or will you use it to make moral choices that bring true peace? Remember, as an apprentice in science and in life, you are building your future right now. So master your tools, insist on precision, and let your spirit guide your mind toward real wisdom. Thank you so much for joining me today. Keep asking those great questions, and I'll catch you in the next explainer.